Okay, so now we're starting again. Okay, so basically, you guys have the code structure for the base robot. What we're going to be doing is going over here. I'll just paste this here. This is where we're going to start. And by the end, so what I'll do is I'll go over a few of the main concepts. So we'll have like maybe like bullet pointed of the main concepts and how they all relate to one another. And then we'll actually look at an example. And I found a starting example, which might be a very useful base to start from, okay? So, software, okay, blah, blah, blah. Okay, no. WPILib, no. Let's see, programming basics. Let's start here, not VS Code, not dashboard, not that. Basic programming. Okay, so let's start here, okay? We're gonna start with joysticks, okay? So, can you start a list or something? Let's do one. Joysticks, okay, okay, so joysticks, okay? So we're starting at the very basic. So you know how you have joysticks. Let's see, where does it start? Okay, so I'm gonna use a code example, okay? So the first thing is joysticks. This is a code example which I think we're gonna potentially use, but I'll show you. So what you do is there's different types of inputs. There's joysticks, and then there's like, I don't know, let's just say joysticks. How you create a joystick is with something called Command Xbox Controller. So I'll put that in here and take notes as we're going along. Okay, so what you do is you can instantiate using create new joystick with via this. Okay, something like that. And what you can do is once you've created that joystick, you can do controller dot, oh, that's not right. The heck, that's not right. Oh, I see. Okay, so you create a controller like this, okay? And then let's just go into here. What you do is controller dot, and you have a bunch of different methods on it, okay? So let's look at some of the different ways that you can, okay, so you have different controllers. You have a joystick, you can have an Xbox controller. As you see, that's what we're using here. And I'll show you what this Command Xbox controller thing is. You can do PS4 controllers and so on, okay? Let's go into the programming section. Where's, this isn't like, let's see, okay, that's not so helpful. Advanced programming, commands, controllers. No, that's, Okay, it's just not working. So let me go over. So what you do is, oh, my computer froze. Okay, so you can do controller dot, and let's see what we have available to it. Again, the idea is that we're going to be documenting what Joy6 can do. So like it's like a very easy intro. So what do you see that we have here? Are you there?
Yeah, I saw that you can get a value from it.
Yeah, so let's say, okay, so on an Xbox controller, there's like the buttons and then there's the joysticks. So if you want to do something with the button, let's say when you click the A button, okay, you can do that. And this is, look at what you have available to it. You have on true, on false. So that's like saying when you right when you press the button, you're going to you know let's see here. Let's back up. The first time I you know, start again from scratch, it's kind of like hard to figure out how to teach, but let's try this, okay? In the structure of the program, you have the controller, okay? Let's go to command-based. Where's command-based? Advanced programming, command-based programming. So what we're going to be using is something called command-based programming. And the idea is, let's go to what is command-based programming, is there's a few different concepts. And actually, I did a very good job at explaining it a while back. Do you remember? Right here.
Yes.
I did that.
Yeah.
Right? That's good to put in here. So let's put that down here. Okay, so let's look at what I wrote because I already did a lot. And let's compare it to this. So there's a methodology of robot programming called command-based programming. Basically, the idea is that you have three different concepts. You have a trigger, a command, and a subsystem. Okay. So what do you guys think these all mean?
I think that the trigger would be kind of like what you're pressing. Like if you have a controller, the trigger would be like pressing an A button.
Okay. Yeah.
And then a command is what that A button deploys to the robot. And then a subsystem describes it all.
Yeah. So here. This is the command-based programming kind of logic. So what you do is your robot is basically at the high level taking your controller inputs, and it has to convert it into actions to subsystem or commands or what's it called? Signals to actuators. And then I really motor 1, motor 2, and so on. Okay. So then you can have this, and this, take all of these. Let's say subsystem, this subsystem has 2 motors, this has 2 motors like that. Okay, so this is command-based. This is command-based. So command-based, basically you have to find basically the robot is all about just taking your controller and getting the motors to do something, right? That's what it is. All of this here is there to structure your code so that it's like, it actually is possible to do this. Does that make sense?
Yeah, that makes sense.
Okay. So basically, let's start with controller inputs. How do we create a trigger? Okay. So for that, let's actually go to the joystick. So where's that? Software overview. There's like a thing on joysticks we were just looking at. Where's that? Hardware.
And it was in basic programming.
Ah, okay. Programming basics, nice. Joysticks. So let's take an Xbox controller here because that's what we're using. Here. So here's an Xbox controller, okay? So what are the different types of triggers that you can see the Xbox controller generating? Can you list a few of them?
We have the 4 buttons.
So when I press a button,
Yes.
okay, number 2.
And then when you like rotate or move the joystick itself.
Uh-huh. And then also, so buttons on this are, right, there's these 4 buttons, there's this button, there's this button, and then I think these are actually just buttons.
Yeah.
And then wait, what are the different joysticks on this?
Oh, there's
How many joysticks are there?
There's 2. There's one on the left and one closer to the center.
Okay, so what's the difference between a button and a joystick?
I think joysticks have more variables because you can move them in any direction, while a button is only true or false.
Yep. So a button is on or off, and then a joystick is -1 to 1, right? And it's anything in there. How many buttons are there? There's 1, 2, 3, 4, 5, 6 buttons. And then how many joysticks are there? This is a little tricky.
Oh, 3?
Well, if you can, do you consider this 1 joystick or 2?
1.
Well, so it is 1 joystick, but in the code, there's actually 2 axes on this. Right? There's the X and the Y. So fine. So when I move the axis, let's call it, how many axes are there on this?
It's either 4 or 6. I don't know if
Exactly. What are the other 2?
The little plus pad.
Oh, interesting. I think this plus are actually buttons. Is it? I don't know.
I think you can move them press it diagonally as well.
Okay. I don't know about this. We can look into that further. But there's actually, you know, the 2 like triggers on the back?
Yeah.
Those are also axes.
Oh, okay.
Okay, so there's 1, 2, 3, 4, 5, 6, and I don't know what this is. Okay, so each of those can be, you can attach a trigger to it. So, okay, so what can you do for a button, which is on or off? What are the different kind of like triggers that can be associated with this on or off? Button axis. It can be when I start pressing, when I stop pressing, while I am pressing, while I am not pressing. Does this make sense here?
A little bit, yeah.
So yeah, it's a little, okay, so when I start the press, which means right when I tap the A button, something is gonna happen. But as if I hold the A button down, nothing's gonna happen. So it only does it once.
Okay.
So for example, what's an example of when I start pressing? Either move, tell arm to move to angle, right? So let's say I want to move my arm to a certain angle. I only have to tell the robot once, set the new set point to this angle.
Can you also do the same thing for the intake? Like when you press a button,
Yeah.
it opens, closes?
Yeah, how about start intake? Right? So these are like two examples of different commands, right? These are actually commands here. Tell arm to move to an angle is going to be one of your commands. Start intake is going to be another command, and that's exactly this command here. Okay. So, and these are like robot functions. Okay. So when I start pressing a button, tell arm to move to an angle or start intake. What about when I stop pressing? Here, how about this? Let's do this one first. While I am pressing, what is a command that you can think of on a robot that should be continuously triggered while you're pressing?
Maybe the angle is moving or like the elevator is rising.
So say that again, please.
The angle keeps increasing, or you can make it as the elevator is rising up.
So that's so what you're saying is while you're pressing move elevator
Like
to
a +1 or like a certain increase per like second pressed or something similar to that.
so while you're pressing, keep making the angle go up?
Yeah.
Okay. So while I am pressing, keep increasing elevator angle. Elevator height. So this is interesting. We'll get to this, but there's something where most of the commands can actually be when I start pressing. It's a little tricky, but so this is a good enough example, right? And then axis, what are some of the different things we can do with an axis?
You can have it control the drivetrain so that you have more freedom in the orientation of it.
Yeah, let's just keep it at that. That's a pretty good command. Okay. So does this make sense here?
Yeah, but what would it be for stop pressing?
I'm not sure just yet. we'll get to that. Let's fill this out more, okay,
Okay.
as we go. So something else here can be 0 sensors, okay? Because you only have to tell it to 0 once, but you don't need it to continue zeroing it. Okay, so let's see how to do this in the code. Oops. WPI lib. Let's see how to do this in the code, okay? Create new project. Let's start very basic. So let's start with a template, Java, command robot, which is what we're using. Let's do the skeleton version. Base folder, let's see, is documents and robot test, and then team number 4. Let's generate project in a new window. Okay, so let's see how we can do this. Okay. So if I go into SRC, yes, I trust the authors.
Oh, so
SRC
you don't.
Java.
Sorry to interrupt, but
Yeah.
so you don't have to create the .vs code or .wpi lib from scratch.
Mm-mm.
Right.
You can always start with a base.
Okay.
And the
got
one I used, so you can go up here to there's a little icon, and you can do create a new project. There's many different project types. There's a template, which is like no functionality in there, but it's just scaffolding it out for you. Or they have examples. They have like Java examples for a bunch of different things. Okay.
Okay, got it. Thank you.
Cool. Yep. So maybe add that into the documentation. So basically, you have in your robot container, this is like the very basics. So let's actually create, let's create a button. So let's instantiate an Xbox controller. How do you do that? So in here, in this robot container, we can do Xbox controller, driver controller, this. Okay. And I'll have like, okay. So what I've just done is I've created a new driver controller. It's an Xbox controller. And this port is like the USB port that you put it into. Okay. So let's actually create remember I said that this is a trigger here?
Yes.
So let me show you something. So if I do driver controller dot, let's say A, okay? And I do on A dot dot is it this? Get a button. What is this? Return a Boolean. No, that's not what I want. I want to get a trigger. So let's look at all of this. How do I get a trigger? Okay. So the first step whenever you have an issue is you can go to the documentation. So let's go to command based. And if you see this right here, let's look at how you like get a joystick. Oh, oops, I know why. This is an Xbox controller, but I actually want Xbox, is it called command Xbox? Yeah, I want a command Xbox controller. And I'll show you why. equals new command Xbox controller. Okay. Here, so dot, yeah, there we go. So this command Xbox controller, if you do the .a dot, you'll see that you have different methods to call. And again, on true, on false, while true, while false. And you see all of these, this right here says trigger, right? So each one of these creates a trigger object. So let's do on true, okay? Oh, can I do that? What's on true? Okay. Okay. On true, okay. So what I've just done is I said on true, but then, okay, so I have to pass in a trigger. So on true is there. Let's take something like this. New run command. To run. How do I do this? System dot out dot print ln rest button, and then this is that. Okay, on true. Why is this here? So let's look. Can I? Okay. So let's follow the instructions, okay? So what I've done is I've created, I thought on true. Let's see here. Trigger test is equal to that. So this is a trigger, test dot on true. So if you go here, you guys still with me?
Yes.
Okay, so how does this work? Let's create a command. So how do you create a command? Let's see here. How do you create a simple command here? The is finished. Do you guys have any ideas? Hello?
We can maybe make a like a imaginary drivetrain and set it to make a command for it to reach a certain destination,
Okay, good.
a certain set of coordinates.
Here, yeah. Okay, so let's here. So there's something called command base. Okay, so I'm looking back at my documentation and I really want this to be, interactive. So let's actually just create, can I do like class test command extends command base? No, it doesn't. It's deprecated. Okay, extends command. Here. So I guess we don't use command base anymore. Okay, so now let's go like that. What do we have available to us?
Where's command defined?
It's defined here. And remember, as you start typing, you can do like control tab, and it'll bring this up. If you just click, it'll import it for you.
Okay, got it.
So there's an initialize. So if I look over here, where is it? Here. Okay. So there's an initialize method, which is when the command starts up. When the command is first called, this is run. This is called exactly once per time. And then in the execute method, this is called repeatedly while the command is scheduled. Okay, so let's just go inside of here, do test command initialized, okay? And then let's do, if we do that, execute. Okay. And let's do system.out. Okay. So let's do that. So now I have a test command. So now maybe I can just do new test command. Yeah, perfect. So you see this is seems to be working. So now there's no errors at least, right? And so now let's actually try to get this to work, okay? So what we can do is we can go over here and do simulate robot code. I'm hoping all of this will work. Okay, if you click OK, you should get the simulation popping up over here. Yeah, perfect. So you see this robot simulation? So now the code is actually being simulated. It says here that there's no joystick on port 0. So you can take your keyboard and drag it in as a joystick. Then watch as figure. Well done. Robot. Okay. So let's see, why isn't this working? Let's see if we get this. And this is how you really debug. You just, oh, oops, I know why. It wasn't enabled. The robot wasn't enabled. So you see here, I put a log that says robot container initialized. And here it says robot container initialized. So this is running, but I think that the commands are all, when you're disabled, the commands don't run. So now if I go to teleoperated and I hit the A key, you see this?
Oh, yeah.
We see test command initialized and test command executed. And remember, as I said, every 20 milliseconds, like there's the code is being run, right? So every 20 milliseconds, there's this executed thing. Whoa, whoa. Does that make sense?
Yeah.
Whoa. Oh, you see this on true? Why isn't this? Uh-oh. So if I just disable it. So why wasn't this, why did this keep going? If that makes sense.
Because
Oh, do you know
you
why?
kept pressing it?
No, I did not keep pressing it.
Oh,
Untrue.
yes.
Untrue means whenever it goes from false to true. But after I press it for the first time, it keeps being true. So it never stops. If I change this to while true, only when I'm pressing it should it work. Does that make sense?
Kind of.
Okay, so if I press this, oh,
I
oops.
understand the while true, but I'm still a little
Do you see that
confused
right here?
on true. Yes.
Okay, so what I'm gonna do is, what is the code to make it so that when I press the B button, I execute test command?
Would you use on true?
Hold on. D2D. Okay. So I want to make it so that when I press the B button, it executes the test command. Oh, okay. So here, look. So I want to attach the B button to a command. How do I do that? Driver controller dot
Yes.
what?
Dot B, since
B, yes.
that's, yeah.
And then let's do while trues for a
Okay.
second, okay? So if I rerun the program, and again, this is using my keyboard, and I know that Z is A, oh, X is B. This is cool. So Z is A, X is B, C and D. Okay. So when I go in teleoperated, you see that?
Yeah.
And then when I press B, that's happening. Now, let's say, for example, for a second, I want to have, when I press the A button, I want to print out test command executed A. Or if I press the B button, I want it with B. Does that make sense what I want?
Can you
I want it to
rephrase
say
that?
like this. If I press the B button, I want this to say test command initialized B,
Okay.
executed B. How do I do that?
You would assign a trigger to it?
So the trigger is the same. The trigger, it doesn't matter. It's executing test command. But I want to pass in another property which distinguishes this one from this one. Okay, does that make sense?
Yeah.
So I want to put in test command, and I'm going to put in A here. Okay, test command B. So now these are different, right? When I press the B, the same command is going to execute, but with a different parameter that we're passing in. Does that make sense?
Yes.
Okay, so this is called a constructor. Whoa, what just happened? Okay, so now I have to go into the test command and say test command. Nice. I have something called GitHub Copilot, which like finishes my code for me. So look, see
nice.
this test command here?
Yes.
If you make it with the same name, this is called the constructor. Okay.
Okay.
And this says, oh, I'm allowing you to pass in, or I'm expecting a name here, which is a string. Okay. So now, okay. So now I want to see this name here. If I just go like that and restart, you're going to see something interesting, which is over here. Oh, I need to bring in the joystick. And now look, if I do, see, you see this? Test command initialized B.
Yeah.
As I hit the B. Wait, what? B. Oh, it's always B.
Oh.
Initialize. Oh, I just hard coded it to B. But the constructor, there should be constructor. It was where is it? Yeah, here, look, constructor A and B. So now I want to make it so that instead of B, here's this name. How do you think I would do that? Using something we learned a while back. This is a class.
Yes.
And what is a class made up of? Two things. Methods and
Methods and
Objects.
and variables.
Oh.
Or yeah. So what I can do is I can say string my name. Okay. I can do something like that. Okay. So this is a member variable. And whatever's inside of my name can be used throughout this class.
Oh.
Okay.
All right.
So what do I have to say here to save this name, which is coming in to this member variable?
Oh, what does super mean?
Don't worry about it.
Okay.
It's basically like calls the constructor of the thing that's this thing. You can just ignore it for now, though.
All right.
You can do this. So what does this do? So let's take a step back for a second. When the robot starts up, this robot container thing is called. So you're going to see robot container initialized. Then it's going to see this line and it says, oh, there's a test command A with you're passing an A to this test command. So we go up here to test command. And you know, when you use the new keyword, this is called the constructor. It's a special thing that's called if it's defined right when this has the new keyword. So this test command, you know it's a constructor because it's the same name as this class. Other ones have to be different. Here, you're passing in this string name. If you don't have this, then this name is just gonna like go, this command is gonna forget about this thing passed in. But if you do this, then you're saving it to a member variable that you can reuse throughout. Okay?
Okay.
Does that make sense so far?
Yeah.
So then all I have to do here is that. And all I have to do here is that. So now, if I rerun the simulation and I put back my keyboard, and I go into teleop, watch when I press the A button. Do you see this? A is
Oh.
passed in. When I do this, B is passed in. See that?
Yeah.
Okay, so now let's take a step back, because we are now, what have we done so far? We've created an Xbox controller right here. We have created different triggers. In this case, we attached it to the A button, and the event that we're listening to is while true. While true, going back to your question, it starts a given command when the condition changes from false to true. When you stop, right when you start pressing it, it is triggered for the first time, or it's available. Sorry, maybe not available is the right word. The command is activated when you press the button for the first time, and it's left running until the condition it changes to false or you stop pressing the button. And this is exactly what we see. When I press the button, it's going, but when I stop it, it stops.
Okay.
Okay. And we attached this this right here to a command. And this is really like almost all of how the architecture works, or the paradigm works. Really,
Okay.
you just take triggers, you create a trigger from the joystick. You say, I want to execute this command. And then inside of the command right now, all we're doing is our command is just printing something out. But now the next step is to take that, and the command takes this and says, okay, in order to issue, or in order to get this command working, no, in order to fulfill the command, I have to go to the subsystems and say, okay, drivetrain, you have to do this. ARM, you have to do this. And the command is kind of like the coordinator between the subsystems. But if, for example, so let's say something very complex as auton, okay? Autonomous mode, you're gonna have a command to run autonomous mode. But what is autonomous mode gonna be doing? It's gonna say, drive to here, and then, or while you're driving, get the elevator to this height and blah, blah, blah. So you'll see that the auton command, so a command, let's see here. A command is like coordinating robot to do something useful. Okay. So command could be, so what are some different commands? Let's say for the drivetrain. What are some different commands that you can think of?
Driving forward, backwards.
So what does that mean, really? Like driving forwards and backwards?
So it's like spinning the motor clockwise and counterclockwise.
Spinning the motor clockwise? Okay, well, yeah, let's take a step back. What do we want to do from a drivetrain point of view, high level? We want to operator controls drivetrain, right? So either the operator can control the drivetrain. So, or drivetrain could be like path planning plus follow path. Do you see how these are two different types of commands that the drivetrain can do?
Kind of. Is it saying that you either control it manually or you have a pre-planned direction, right?
Yep.
Okay.
So the drivetrain can be in manual control. This is also called open loop control. And follow path. This is called closed loop control. Okay. Perfect. So now, let's do drivetrain, and let's do flywheel. Okay. What would flywheel be? You know what a flywheel is?
Not
Like
exactly.
it's a shooter with a big like wheel that spins super fast.
I might know.
It looks like FRC. If you want to shoot a ball,
Yeah.
into a hoop, you spin a wheel super fast, and then you feed the ball up, and then it shoots out. It's a shooter.
Okay.
Flywheel or shooter.
It can
Okay.
be triggered by a button.
So okay, so the a button, yeah. So button press.
And then I'm not sure if this is correct, but you can also get it to like a certain time after you do a command, like after something is picked up and a certain time passes, it shoots it.
Okay, so let's just get the fact that, let's say I have the ball in the, so here, how about this? How to shoot a ball that you possess. You can say, like, let's say, press a button, right? So you press the A button. Okay. And that's going to what? So this
It's
is
going,
the trigger, right?
yeah.
Okay. Okay, so what is the command? When you press the A button, what do you want to do?
We want to repel the object you possess.
Say that again?
You want to repel the object that you possess.
Okay, so what are the steps in order to do that?
You would make probably a class.
No, just high
No?
level. What does the robot have to do? It has the ball right near the shooter.
Mm-hmm.
Or let's say it's in the robot. What do you have to do?
You need to tell the robot to rotate the motor so that it so that the shooter can repel it.
So yeah, so you want to start flywheel spinning start flywheel spinning. You want to start the flywheel. How fast do I want it to go? Right? When you say, okay, start flywheel. When flywheel finished, when flywheel at speed, what do I want to do?
we want to, if it's at the speed, then we want to release it.
What does releasing it mean?
Releasing it means like opening the shooter or the intake so that it like shoots out.
So how about this? Wait for flywheel to be at desired speed. Okay. Number 3, right? Because you don't want to start the flywheel and then shoot the ball. You have to wait for it to be at the correct speed. So start flywheel, wait for it to be at the desired speed, then what?
Then we
Feed ball into flywheel. And then done. Right? That's how to shoot the ball. Right?
okay.
These are the steps that you need. There might be another step in between this and this. Can you think of another step? You have to aim.
But don't you aim with the drivetrain?
Yeah. So shooting a ball isn't just about the flywheel, the feeder, or the conveyor, and it's also the drivetrain. So shooting a ball is really like 3 steps. There's 3 steps. Right? But what you want to do is you want to have all of this happen. Start flywheel, aim with the drivetrain, feed ball into flywheel. You want all that to happen when you press the A button. Okay?
Okay.
So let's actually program this in. And we're going to be, what's it called? We're going to be mocking out some implementations, but we're going to get this thing to work, okay? So you see, I have it as the trigger to command to subsystem to the motors.
Yeah.
This right here can actually, right, like you could put all of this into a single command. Or you can do something, right? So this right here, a command is just a list of instructions. Tell the flywheel to do, tell the subsystem to do this, tell the subsystem to do this, tell the subsystem to do this. Or what you can do is, and that this is a complicated command. This is a complicated command, right?
Yeah.
So there's 2 options, and we'll code 1 or 2 of them. So options. Okay.
Can you make all the commands separate and then put them into one overall command and execute them?
Exactly. Yeah. So there's option 1 is single complicated command. And then you can do small commands and put them together. And what's really cool about the small commands and put them together is once you create one command for this, one command for this, and one command for this. Once you create these 3 separate commands, if you want the B button to do something else and you have to start the flywheel, you can reuse this command. You see that?
Yeah.
So that's actually a great thing that you came up with. So how do we, what is the, my head is going to the word primitive, but like, how do you actually get that to work? So that is something called, let's go back to the command. Is this helpful, by the way?
Yes.
Okay. So let's go back to command-based programming. So there's commands, which has the initialize, execute, and then there's an end function. Okay, this is going to be important, I think. A second. Let's just go over this really quickly. The end method is called once the command ends, whether it finishes normally, is finished returns true, or it was interrupted. So let's focus on, for a second, this over here. If we have it as 3, right? Start flywheel. So the start flywheel is going to be in the initialize. Depending on how you do it, it can be either in the initialize, which is set, it tells the flywheel, it sets the set point to 1500 RPM, which is a speed. Or it can actually be in the execute, where the execute you say, because the initialization, if what you tell the flywheel is set your set point to this speed, you can then not tell the flywheel anything else, and the flywheel will be responsible for getting it to that speed. Does that make sense?
Yeah.
Or you can have it like in the execute of in the command, you can say, what's your current speed? Oh, your current speed is this. Well, I need to get it to 1500, or the target. So therefore, I need you to, set the motors, sorry, that's a little confusing.
I understand, kind of. I understand what you're trying
Okay.
to say, like with setting.
Sure. So there's 2 ways of, so at the end of the day, to get the flywheel to the right speed, somehow you have to check what speed you're at now, and you have to check where you want to get to. And from that difference, or that calculation, you have to say what the motor should be set at, right?
Yeah.
Like somehow you have to do that. You can do it in 2 places. One, you can tell the subsystem to take care of it, or you can have the command take care of it.
Okay.
Does that make sense? Is that a little more clear or not really?
Not really.
Okay. So that's fine. So we'll get to that in a minute, okay? But so that, we'll put it on the shelf for now, but we'll get to it in a few minutes. Let's focus high level on the command group, or sorry, going from one command to the other. Okay, how are you going to know when this command is finished? There's inside of the command, so here, inside of this command, right, there is an is finished function. So look at this. Let's rerun this. And do you see this is finished is false?
Yeah.
So what does that do? When I go and teleoperated, see that it keeps going?
Yes.
Oh, here we go. Okay. What happens if I do this? Hold on. Int counter equals 0. Counter equals 0. Okay. In the execute, what if I do this? Counter plus equals 1. Return counter greater than 10. What if I do something like this? See that? I'm holding the button, but it stopped.
Yeah.
Why did it stop?
Because of the counter.
Say that again?
Because of the counter.
Yeah, because this is finished method. So this is finished method so whenever this returns true, that tells this command, stop running, stop doing this execute because we've already finished. Does that make sense?
Kind of.
Okay, so let's investigate that because that's important. So explain to me what your current understanding is.
Well, I understand that when you press the button, it starts the test command initialize.
Mm-hmm.
And then it goes to executed, but since we have the counter, it sets it at a limit so that it's forced to come to an end after it goes over a value.
Yeah, so let's try it again. Oh, oops, IntelliUp. Now tell me what this is doing. It stopped after 10.
Yes.
Why did it stop?
The counter says that it returns greater than 10, so it has to stop once it reaches the 10 mark.
One second, let me just try something. No. There is something I don't understand. Okay. So basically, what happens is right when you start this command, it executes whatever's, well, this is the constructor. Then it runs this initialize once, and then it runs this execute, okay? And then actually after the execute is called, it checks to see if this command is finished. In this case, we're like arbitrarily saying it's finished once your counter is above 10. But for example, going back to here, the start flywheel command would be what?
It would be
What would the ending condition be?
the ending condition could be is finished when it's at the speed.
Yeah,
What?
you ask the subsystem, what speed are you at? Are you at your desired speed? If so, my job here is done. Does that make sense?
Okay, yeah.
Cool. Okay, so this is finished is going to be helpful for what we're trying to do here. I want to show you something. I hope this will work. I think it will. Oh, got it. Is Um, ah, got it. So now there's another method. Let's make this 100. Okay. Now there's another method here called end. Okay. So now let's run this. Again, oh, yeah, okay. So here, put the keyboard here, tally up. Let's look at this. End. Oh, let's rerun this. Okay, here. Okay, you with me?
Yes.
So let's say if I hold this all the way down, you see this? It ended, right? So what happens is each time, okay, at the beginning, it was initialized. Initialized was called once, right?
Yeah.
Then every single loop executed is run, and executed just prints this out and increments the counter. And that keeps running, right? Is finished. Oh, and then, so sorry, execute is called, and then is finished is called to check, am I done? No, I'm not done, because the counter is 1, and 1 is not greater than 100. So I call execute again. Then I check, am I finished? No, execute is called again. Is finished check. Does that make sense? And that's the same thing.
Yeah.
Until we get to counter was bumped up from 100 to 101. You see this? When executed is called at 100, now it's bumped up to 101. When is finished is called, the counter is at 101. So it is finished. So this returns true. You see that?
Yeah.
And when that returns true, then this end function is called. So the end function is called right over here at the very end. So one more time, and then I want you to ask questions. Initialize is called right when the command starts up, and end is called when the command is done.
Mm-hmm.
And then every loop, execute is called, and then is finished is called. Does that make sense?
Yeah.
Okay. Do you have any questions here?
No.
So
At
I have
first,
Yeah.
I was a little bit caught off guard with the interrupted, but then I got it.
well, interrupted, I'm going to show you what that is.
Isn't
You see
it?
that?
Isn't
It says
interrupted saying that like if it's true, then the end wasn't interrupted.
So I
and
just actually made the interrupted true. How did I do that?
you didn't go over the limit.
I didn't go over the limit, but how did I stop the command?
Did you let go of the button?
Yeah. because this is only supposed to run while it's true. So now we know what interrupted means. Interrupted is a way for us to know. So inside of here, this is like, okay, the command is ended, but why was it ended? Was it ended because is finished? The command itself said, I'm done. Or was it that the trigger said, oh, I don't care if you're done, just stop because I don't want you to do it anymore. Does that make sense?
Yeah.
Cool. Awesome. So is that all clear?
Yes.
Okay. We're like, do you see how we're building up to like actually programming? Like doing stuff with the robot?
Yeah.
Okay. This is the majority of, this is how you think about everything. So now let's actually figure out how to make the flywheel. Like, let's actually stub out. By stubbing out, it's like, let's create a flywheel subsystem and like actually, you know, but like mock it out. So we're not actually using the physics or the motors or anything, okay? You good?
Yeah.
Okay, so this command, we're gonna rename this to set flywheel to speed. Okay, good. So this is
Yes.
going to be set flywheel to speed. And so now, instead of this being a string, let's make this an RPM. So let's make this 1500. And this, I don't know. 700, okay? So what this is gonna do is it's gonna say, when I press the A button, I wanna get it to 1500. When I press the B button, I wanna get it to 700. That's our goal. Good goal?
Yeah.
Cool. So the first thing is, I just changed the input from name, from a string to a number. So I'm gonna call this an integer, and this is gonna be called set point. Okay?
Okay.
So this is an int. So this set point here,
Is the set point the initial height? Or not the height, the speed?
so this is, here, let's call it something different. Let's call this desired speed. Good?
Oh, okay.
Set point, desired speed. Good. So now this isn't a name, this is new. Okay. Cool. So now, okay. Cool. So this is the desired speed. So I'm going to comment this out. Oh, okay. So remember how I said there are two ways of going back to, where was it? Like there were two ways, I don't know where I put it.
The options?
Not the options, because we're still doing this option, but within this option, there's either remember how I said you still have to check whether the flywheel is at the right speed,
Yeah.
like, and then do something from it. You can either put that logic in the flywheel subsystem, or you can put that logic in the command. Remember how I said that?
Yes.
Okay. So one way of doing it is this. What we want to do now is we want to create a flywheel subsystem. Okay. So this represents a subsystem. Okay. And now in the subsystem, so what is something that I can do right when the subsystem is initialized?
We can check for
So,
the speed.
so the first thing is when it's initialized, what method is called if it's defined? It's on line 25.
The constructor?
Constructor. How do I, oh, okay. I guess Copilot just gave the constructor to me. So how do I know that this is a constructor?
We know that it's running, like it initialize the method.
How do I know that this function is not just a regular function, but it's a constructor?
Because we have the flywheel subsystem.
Because the name of this function is the same name as the class. Remember how I said that?
Yeah.
Okay. So what I've done now is I've created a flywheel subsystem. Okay. Now the question is, I want to get the command to do something with the subsystem. Okay.
Okay.
So in order for the command to know about the subsystem, just like with this input, I have to tell the flywheel about this flywheel. Sorry, I want to tell this command about the flywheel.
So what would we have to make into a variable?
Exactly. Perfect. So what I would do is I want to create the subsystem at the root in the robot container. Okay. So flywheel subsystem, just like that. Okay. So what I've done here is I've created the flywheel subsystem. And now I have to tell this command about this subsystem. So what I'm going to do is pass in flywheel subsystem. Does that make sense?
Yeah.
So now it knows about the subsystem. Now we have to go back into the command and say there's a new property here called flywheel subsystem. Okay. And then just like this, you'll see that it's starting to repeat itself. What is this flywheel subsystem? What do I have to do in order to not lose, like to not just forget about the fact that this was passed in? What do I have to do?
We need to save it.
Save it.
And then rewrite it. Yeah.
Yep. Perfect. So now the initialize will know about it. Let's call this fly sub. It just can't have the same name as this. Okay.
Okay.
Does that make sense? So now,
Yeah.
Now the command knows about the subsystem. Great. Now, okay, cool. So now what? So there are two ways of doing it, okay? The first is the subsystem. Now let's not focus on this. Now the subsystem needs to know int current speed. Right now the subsystem needs to know what its current speed is, right?
Yeah.
So let's say the current speed starts at 0. Okay. And so now what I can do, one way of getting this thing to work is, and this is the best way, is the command should just tell the subsystem go at this speed, right? I have a desired speed in here. I'm just gonna do like flywheel subsystem dot set desired speed. Okay. To get this thing to work, I can just call this one line and that's it. So let's see how that'll work, right? Because the command shouldn't really care about how the flywheel does it. The command is just giving the command, do this, okay? And then the is finished command can be as simple as return flywheel subsystem dot is that, are you at the speed? And this can be it. Okay. Does that make sense?
Yeah.
Okay. So let's okay, so I'm just cleaning this up a little bit. I'm saying we don't even need this. Is finished and end. So end can just be sys. Okay. So now this class can be done. But now we have to do is set desired speed and is at speed. Okay. And we can now just move set set, what's it called? Set desired speed. Yeah. Okay. So now this is actually not right. So what I need to know in here, this flywheel needs to know its current speed. And it also should know what? Desired speed. It should have two parameters. One, what is my current speed? And two, what is my desired speed? Does that make sense?
But don't we already know our desired speed?
The subsystem, should know what speed do you want me to be called at? Sorry, what speed should I, wait, hold on. The subsystem just knows about itself. It doesn't know about what command or what people wants to do with it.
Okay.
So it should know what is my current speed and what should I be at. And then it's the command's choice to say, oh, the operator wants you to go at 1500, or the operator changed its mind. It wants you to go at 700.
Okay.
Does that make sense?
Yeah.
Okay. So current speed and desired speed. Great. So now I'm going to say my desired speed. Let's say initially when the robot starts up, I want to be at 0 and my current speed is at 0. So what should the is at speed function return?
It should return the current speed.
Well, it should say, are you at the speed? Well, if they're equal to, then it is. So this is it.
Okay.
The condition is the current speed equal to the desired speed? And then what should this set desired speed do?
It should check if the desired speed is at new speed.
No, so this is where I'm purposefully leaving out a piece for you. Okay. So the set desired speed should just say, oh, there's a new speed that somebody wants me to go at. So I just set it internally. Okay. Is this a little confusing or no?
Yeah.
That's okay. So, right, okay, hold on. I see how it's confused. It's a little confusing. Isn't it nice for the command to just say, oh, when I initialize, I'm going to tell the subsystem to go at this speed.
Yeah.
That's nice to do.
Yes.
And then to see if the command is finished, just ask the flywheel, are you done?
Yeah.
Right? That's nice to use. That's nice. Okay. So what the command wants to tell the flywheel subsystem to do is it wants to tell it what speed should you go at, and then just tell me if you're done. So the flywheel now just needs to know, tell me the new desired speed and am I done, right? Because that's what the command cares about telling the subsystem.
Okay.
But then, so now we have all of the building blocks in place to get this to work. But what is the one thing that's missing? What is the one thing that's missing here?
Are we missing the end?
How do I get the current speed to the desired speed? Right?
We need increase it by
Yeah, but we have to
1.
do that in the loop. Remember this command thing?
Yeah.
Had this execute, but we got rid of it.
Oh, okay. Yeah.
Right? That's where the actual work was being done. But now we're saying we're going to find a way, not for the command to do it, but for the subsystem to do it.
Okay.
So basically a subsystem should be what's called a black box, which is,
It's an input and output, right?
yeah, exactly. So you tell it set point targets, set points, and you can ask it questions. Are you done? Okay. But now the black box, you don't care, the command doesn't care how it gets there. The command just like assumes, like asks it questions. So now we get into the third part, which is subsystems. And a subsystem has a periodic function. Okay. And this periodic runs every loop cycle. So what can my logic be? If desired speed is here, let's see. Escape. Let's see what this printed out for me. If the desired speed is more than current speed, then I have to increase my current speed. If it's less than my current speed, I want to decrease my speed.
Do we have to like change it by 10, or can it be a different value?
Any value.
Okay.
I think the numbers here we put is 1500. Let's make this 100 and this 200. Okay.
Okay.
And then let's just keep that at 10. Why not? Okay. So if we didn't break it, it should work. But let's see. Tally up. Oh, starting flywheel to spin at 100, flywheel at speed 100. Oh, don't I have to like register it or something like that? Hold on. Subsystem. Let's check. Okay, so the periodic is working. So okay. So let's try running the simulation again. You see how nice it is to have the simulation? Oh, it just went super fast. Oh yeah, here, look. So let's make this 100, or this one. Okay. And now let's actually say, let's go to the command. Okay. So let's actually make this 1000 and 2000. Okay. You still with me?
Yeah.
Okay. Tally up. Put the keyboard there. And now watch this. See, now it's going up.
Yeah, I see it.
And then maybe I should have kept it at 10. We're almost there. And now then it'll stop. See that?
Yeah.
Now watch this. When I press, you see that? Look. Now I'm pressing the B button. Now it's trying to get to 2000.
Mm-hmm.
But now,
If you press A again, then it's gonna go down.
see, I'm pressing A. Now I'm pressing B. Now it goes up, down, up.
Is
See
there
that?
a point where like the motors will burn out if you change it quickly?
Yeah, so that's a very good question, right? when you're actually dealing with, oh, this is interesting though, hold on. I stopped pressing the button, but it's always going down. Why is that? That seems strange. Oh, got it. Oh, this is cool. Look, sorry, just one quick question, or one quick thing. I'm gonna press the B button, okay? And then I'm gonna let go.
Okay.
You see this? This keeps going even though I'm not pressing the button.
Oh,
Why
is
is
it
that?
because we made it while true?
No, so this actually stopped. The command actually did stop.
Oh.
Let's look
Oh,
at,
is it because of the is finished? Because
well,
it
this
kept
was
checking?
actually, sorry, it was not finished, you're correct. But the end, this was called because, but it was interrupted because I stopped the trigger. Remember we showed that?
Yes.
So this command here is telling it what speed it should go at, what the new target speed is, okay? But this runs every loop. And when I click the A button, my new target speed is 1000, but its current is at 1700. So even though I stopped the command, remember, it's the responsibility of the flywheel to get it to that speed. It doesn't matter if you stop the command. The command was go to 1000. I'm not at 1000 yet. So I need to keep working. And this is, does that make sense? Because when I click the button, the thing that changes is the set point, is the new target. But then the flywheel is doing a good job. It's doing what it's expected to do. It's expected to get to the target. So I'm gonna keep reaching in the target until you tell me, oh, I should go back. So I'm gonna continue back. Does that make sense?
Yeah.
Isn't that cool? Let's take a step back for a second. Are there any questions about this?
No.
So this is the way that I want us to program, okay?
All right.
I want us to program in the following way. In the robot container, you define your mappings. There's actually like a standard of configure bindings. Configure bindings is basically just like, we can just put it here. Bind everything together. Oh. So in order to do that, I'm gonna do flywheel subsystem, like that. Okay. So configure bindings is where you say, you take a controller, you get the trigger that you want, and then that triggers commands. Okay. The commands should then go and issue set points or issue desired states to the subsystems. And the subsystems will work to align their current state to their desired state. Okay.
All right.
So now let's make this 100. Whoa, what just happened? Let's make this 100 and 200. Okay. And now let's actually get a little closer to the Excalibur where we want to. Once the flywheel is up to the speed, I want to start aiming. Okay?
Okay.
So what I'm going to do is create a new command called aim command. Maybe we can always call this command. Okay. Oops. Okay. For now, the aim command is, let's not take in any arguments. I have a new keyboard and it's like not so good at typing. So I'm just gonna do in here system out.println start aiming. That's all I'm gonna do. And then as you see, it's the same kind of thing all the time. So now, how do I make it so that once this is finished, this starts? That's something called command composition. See this foo command and then blah, blah, blah?
Yeah.
So all you have to do, I think, and then new aim command. I think that's all you have to do. Tab. There. I think this is it. So now, let's see. Okay. Simulate. Okay. Now I only want to, oops. I only want to log if it's like not at the desired speed. Okay, so watch this. So now if I hit Z, see that?
Oh, yeah.
Do you see that? Once the flywheel is at speed, start aiming. Now watch this. If I do this, start aiming.
Got it.
Go like this. Once it's at the right speed, start aiming. So you just do, so you're literally just chaining them together. Does that make sense?
Yeah.
It's pretty cool, yeah?
It makes things easier.
It makes things much easier because now if you need to have a very complicated command for auto where you have to use the flywheel, you just say set flywheel to speed and then blah, and then blah. So, okay, so, I mean, I think that's quite a lot, but how was that?
It was good. I was also wondering if you knew how to find things in Phoenix Tuner or the motors, because we were trying to find which port it was connected to, like the ID number, and
Mhm.
um, it, none of the motors were appearing. It was only the power distribution pin.
I mean, that, so the first thing is,
But it was trying to update, so maybe that was why.
so I will say that the API for Phoenix has changed. So here, if you go here, and I'll paste this in here at the top. This is the new API. It's actually very cool. They did a very good job.
Okay. So we should install that one?
Yes.
Okay.
So we're going to be using the new Phoenix API in the code. And then you're also going to have to installing the API, okay? Installing the tuner. So this is how to install the tuner.
Okay.
Here's a Windows, like a link to it.
Is that
And
the one that was with the Slack chat?
yeah. I mean, now that it's almost build season, they released it to everybody.
All right.
But yes. And then why you're not finding them, I don't know. I mean, I can't really know without seeing it.
Yeah.
But yeah, so this was a lot, but basically this is literally how our robot is going to be programmed.
Okay. When you lay it out, it seems very simple.
Because with programming or engineering, like whatever, it really is about making sure that it is simple. It is simple. Like, or because like it's like layers on layers of complexity. So like some robots programs are very complicated. Sometimes it's for a good reason, and sometimes they're complicated because they programmed it poorly. But this is the fundamental. And if we build upon our fundamentals, then it can stay as simple as we can, as we want it to. Then we can add complexity as we want to. But yes, this was a very good like an understanding of what's going on.
Okay, got it.
And so now, I mean, like, really it's about, so next steps are like something that is an added layer of complexity, but I think for good reason. And we can look into that next time.
All right. Thank you so much.
I'm gonna stop the recording. And once it's so recording, stop recording.